a square, and an equilateral triangle. Both of these have all their sides the same. Square has all right angles and all equal sides, and equilateral triangle has all equal angles and all equal sides. All right, both these shapes are the start of very common right triangles that you're going to see. With the square, you simply draw the diagonal and you have two right triangles. We're only going to worry about one of them right now. So I'll erase the other part. So there's a right triangle that's formed by splitting a square in half with the diagonal. So let's say that square had a length of 2 for every side. All right, so it was a 2 by 2 by 2 by 2 square. We split it in half. We can figure out what the diagonal is without even using trigonometry, just good old-fashioned Pythagorean theorem. Remember Pythagorean theorem? You square both the straight sides and add them together. Take the square root of that number. A squared plus b squared equals c squared. Remember all that? So you would square both these sides. 2 squared plus 2 squared is equal to c squared, c being the hypotenuse. 4 plus 4 is 8. 8 equals c squared. And then you would take the square root of both sides to figure out what c is. And when you take the square root of 8, this is where it gets a little tricky. You don't use your calculator. You don't tell me that it's 2.8 or whatever it is. You factor down the 8 and you give me the exact answer with a square root symbol in your answer. So you would factor out the square root of 8 into the square root of 4 times the square root of 2. Right? Because 4 times 2 is 8. And then what is the square root of 4? It's 2. And what is the square root of 2? It doesn't factor anymore. It's just the square root of 2. So your answer is actually 2 times the square root of 2. And if you use a calculator and check this, if you could do 2 times the square root of 2 on your calculator, or just the square root of 8, you'll get the exact same answer. It's the same thing. All right, so this is 2 square root of 2. I'm going to show you one more, and hopefully you're going to see the pattern here. So here's a square that's going to start off with every side being 3 instead of 2. We're going to turn it into a right triangle, and I'll erase the other half of the square like I did last time. Now you'll square both sides and you'll get 9 plus 9, which is 18. So 18 is going to equal c squared. So you take the square root of both sides, you factor 18 into the square root of 9 times the square root of 2, because 9 times 2 is 18. Yes, you could also do 3 and 6, but you always want to try and use numbers that are perfect squares. Like 9, the square root of 9 is 3. You want to use numbers that the square root is a whole number. That's what I mean by a perfect square. So like the square root of 9 is 3. Square root of 16 is 4. Square root of 4 is 2. Square root of 25 is 5. If you could use those numbers when you're factoring, it makes your life a little easier. So square root of 9 is 3. Square root of 2 is just 2. So you end up with 3 square root 2. If I were to change my square and do this again, a third example with every side being 4, my diagonal would be 4 square root of 2. If I were to show you with every side being 5, my diagonal would be 5 square root of 2. The pattern is the diagonal of a square is just the length of the side times the square root of 2. It's a nice little pattern. So sometimes you're going to be asked a question like in today's do section, how do you find the length of a side if you're given the diagonal? So here, let's say the diagonal is 9. How would you find the length of a side? Well, you got to work backwards. How did you get from the side to the diagonal? On these first two examples, you multiplied the side by a square root of 2, right? If you were given the side was 2, what's the diagonal? 2 times the square root of 2. If you were given the side was 3, what's the diagonal? 3 times the square root of 2. Now we're doing the opposite. So what's the opposite of multiply? Divide. It's like if you were getting, let's just leave it at that. So to get from the side to the diagonal, you multiply by the square root of 2. To get from the diagonal to the side, You divide by the square root of 2. So this side length would be 9 divided by square root of 2. However, this gets into one of the points that I want to make today. You cannot have a square root in your denominator because it's an irrational number. You cannot have irrational numbers in a denominator. So how do you get rid of that square root of 2 in the denominator? Well, you multiply by 1, but instead of multiplying by 1, we're going to turn our 1 into a fraction, which means we put it over 1. The reason we're multiplying by 1 is because we don't change the value of 9 over square root of 2. If you multiply anything by 1, it stays how it is. But what's another way to write a fraction that has a value of 1? How about 7 over 7? Yeah, that's 1. How about 6 over 6? Yeah, that's 1. Anything that has the same numerator and denominator is 1. So you can multiply by 8 over 8 if you wanted to, and your answer is still going to be 9 over the square root of 2 because you're just multiplying by 1. So that's what we're going to do here. We're going to multiply by a fraction that has the same numerator and same denominator. What are those numerators and denominators going to be? The square root. It's going to be square root of 2 over square root of 2. Because when you multiply fractions, you multiply straight across, and when you multiply two square roots together that are the exact same number, that square root symbol goes away. Remember, square root of 2 times square root of 2 is the same thing as square root of 2 squared. And when you square a square root, those symbols cancel each other out, and you're just left with the number inside there, 2. Okay, if you don't believe me, think about square root of 9 times square root of 9. If we were to do square root of 9 times square root of 9, what is the square root of 9? It's 3. So it'd be 3 times 3. And what's 3 times 3? 9. So the square root of 9 squared is 9. You just cancel out those symbols. So it works for every single number. If you multiply the same number together and they both have a square root symbol over them, you just get the number inside there. So now we're not going to have a square root in our denominator anymore. We're just going to have a 2. And in the numerator, those aren't, you can't say that's square root of 18. You don't combine those together. You just say it's 9 times square root of 2. That's how you would label the side. 9 square root of 2 over 2, and you can check in your calculator. If you do 9 square root of 2 divided by 2, you're going to get a decimal. That's the exact same thing as if you do 9 divided by square root of 2. So they mean the same thing. They have the same value, this and that. It's just now we don't have a square root in our denominator, and that's a good thing. So this working backwards, you're going to have a problem in the do section today that gives you the diagonal of a square, and you have to find the length of a side. That's how you do it. You divide by the square root of 2, and then you get rid of that square root in the denominator. All right, here's another one. It's called the 30, 60, 90 triangle. This one that I just showed you is called the 90, 45, 45 triangle. Because when you split a square in half with a diagonal, you're splitting those 90-degree angles in half in the corner. That's a, oops. And you get two 45-degree angles. All right, now here, when you split this into a right triangle, you're going to have to draw the height of the triangle. The height of the triangle is a line that goes straight down from the top to the bottom at a 90-degree angle. Now we've just made a 90-degree angle, or triangle. Just like we did with the square, we split it in half with the diagonal, made two 90-degree, two right triangles. Now we split our equilateral triangle in half with the height and made two right triangles. We're just going to worry about the one side. So before I erase the other side, let's just use 2 again. Say every side was 2 on our equilateral triangle. When we draw the height, we split the bottom in half. So now each one of these parts is 1. And what would the height of our triangle be? Well, we'd have to use Pythagorean Theorem. We'd have to do Pythagorean Theorem to find a straight side of a triangle. So now it's not 2 squared plus 1 squared. You add them together when you're looking for the hypotenuse. Now we're looking for a leg, a straight side. So now we're going to have to subtract. So it's going to be 2 squared minus 1 squared. is equal to our leg squared, which you could call A or B. That's actually supposed to be an L. Sorry, I know it looks like a C, an L for leg. All right, so 2 squared minus 1 squared is 4 minus 1, which is 3. So you have to take the square root of 3 to figure out what that leg is, and the square root of 3 doesn't break down, so it's just square root of 3 is the leg. And this right here is a very common right triangle that you're going to see. It's called the 30, 60, 90. When you split that top angle on your equilateral triangle in half by drawing the height, you turn that 60-degree angle on the top into two 30-degree angles. So this is a 30-degree angle on the top, a 60-degree angle over here. So a 30, 60, 90 and a 45, 45, 90 will not be going away. You'll be using those for the rest of your high school math career. Now in today's problems, you're going to have to find sine, cosine, tangent, and one of the sides is going to be a square root. So let's just use the 30, 60, 90 one again. So say this is 30, 60, 90. So this would be 1, 2, square root of 3. Like that. So you've got this. And the question is, what is the tangent of 30? Well, this is just SOHCAHTOA. It's a little bit easier than yesterday. You're not solving for a missing side. Tangent of 30 is just SOHCAHTOA. So tangent of 30, SOHCAHTOA is TOA at the end. Tangent is opposite over adjacent. So the opposite side of 30 is the side that's not making up the angle 30, the 1. It's across the triangle from it. So 1 is opposite of 30. And the adjacent side is the side that makes up the angle 30 that is not the hypotenuse, the square root of 3. So it's 1 over square root of 3, which if you didn't see this lesson today, you would leave that as your answer. And if I told you were wrong, you would be mad because how is that wrong? That's SOHCAHTOA. It's wrong because you can't have a square root in the denominator. So what do you multiply by? 1, but you turn that into a fraction using the same square root as your denominator. So you multiply straight across, and you get 1 times the square root of 3, which is just square root of 3, and the denominator turns into a 3. So that's your actual answer, square root of 3 over 3, not 1 over square root of 3. They both mean the same thing. If you turn them into decimals, they'll both be exactly the same, but mathematicians are picky. You can't have a square root in your denominator. So if you get an answer today in one of the problems that has a square root in the denominator, get rid of it using this method and make sure your answer looks like it's in this form here. Ooh. I can do a circle motion in a reflection of a mirror. Just try that. It's hard.